Hello. So yeah, I will start my today's coding practice. Okay. So today's question is our search suggestion system from LeetCode. So yeah. So let me get started. So the question is this. So you were given an array of strings, product, and the string search word. And so I will be given product and search word. Yeah. So this is array of string and this is string. Okay. So design a system that suggests at most 3 product names from product after each character of search word is typed. Okay. Suggested product. Suggested products should have common prefix with search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum product. Okay. Return a list of lists of the suggested products after each character of search word is typed. Okay, I see. So in this question, I will give him so let me clarify the interface of the method I will be implementing, and also let me do the confirm the data input. Yeah. So in this question, I will return the list of suggested product after each character of search word is typed. Yeah, okay. So okay. So this is the implementation of, interface of the method that we're implementing. So list of list. Yeah. Okay. Search word and product and search word like ABC, product like cat or dog or something like that. I see. Okay, so let me think of this question with some examples. So first 3, I will think of the case when for first example, product is a cat and cotton and maybe a alert, apple and banana, cat, cotton, and dog, and time. Okay. And say if I'm the search word is like A, maybe B, button. So in this case, okay, when I type the first word B, oh wait, let's okay, so one thing I can confirm is as the specification of this method is whether I should okay, so let me let me ask it right there. So let me do quickly something. So when I put only B, the suggestion should be return cat, cotton, dog. I have to return only 3. So these are the words which should be suggested. Okay. However, if I type B, no. I should return banana. Because as long as I type this B, I have to find the product names which begins with B as a suffix, and the only words which meet it is banana. So this should return only banana. Yeah. Okay. And then when I type BU, there isn't any word which begins from BU, so this should be empty. Yeah, and same for the, when I type next T, also next T, next O. Yeah, how many, no matter how many I type anymore, all of them should be empty array. Because there isn't, yeah, any word which begin with that, yeah, a substring. So in this case, I will return the array of banana, empty. Yeah, this one. So one thing I'd like to confirm is, should I written something for the case I didn't put any character? So should I include something as the first index or not? That's what I'm wondering. So I will take a look at LeetCode question, confirm it. So this returns 1, 2, 3, 4, 5, and search word is 5. Okay, so I can work with the case when at least one character is typed. So I don't have to include this. Okay, so yeah, my understanding of this question is clear. So let me think with one more case when the suggestion works more, works in a better way. So let me think with banana and bun and butterfly and bed, bench. Yeah. Battery. Yeah, I think this is a good example. So if I get this, and if I get, say, search word is butter, then what I should return is, firstly, when I type only B, oh, probably what I should think first is I should sort it. So banana bond, I'll begin as T, buttery, butterfly begins first, okay, and bed, okay, bench, okay. Yeah, already sorted actually, but okay. So if I type B, I should find the word which begins from B. So all of them begin from B, so every word is fine. However, I will return the Rex graphical minimum 3 products, so it should be banana, bun, butterfly. Then if when I type, okay. Type A, I need to find the word which begins from BA, so it should be BA, and so bed and bench, they are not, possible anymore. So I will return banana, bun, butterfly. Then when I type next T, let me add one more word. But, sorry, please forget it. Okay, when I type BAT, battery and butterfly and battery two possible words, and both of them, yeah. So I just have to return both of them. Then when I type next T, the same. And when I type next R, both of them are possible. Yeah, so I will return both of them. So yeah, in this way, I will return the array of, yeah, to the array of running 28 to 32. This is the thing. Okay, so now my understanding is clear. So let me think of the algorithm, how I can do it. So one of the naive approach I come up with is that, so firstly, I will sort product, and then for each suffix of search word, so find them. Yeah. So this is, I think, the naive approach I can use. And let me think of how much this takes. So okay, so assuming that n is number of product and also search words. So also it depends on the word ranks. So let me put an assumption premise that each of the word in product and also search word ranks are the same. Yeah. So with this assumption, let me assume do the complex analysis. So in this case, the time complex should be, firstly, I have to sort it. And also for each suffix I put type, I have to find the, word which begins from that suffix. So to find out the first word which begins with the suffix in product, I will use the binary search. And because each element has ranks to L, the binary search takes this much time, L log n. Then I will look at three words. Yeah. So find three words from that. So basically this is a time complexity, and it should be n plus L log n. Yeah. Okay. So that's the thing. So for space complexity, the sorting takes n plus, for temp sort extra space, and also an L for the ranks of the words. Yeah. So it should be an L. Okay. But probably I can speed that up with using the Trie data structure, because the thing is that what I did in the brute force approach is that for every suffix of the search word, I traverse of the product array, And the thing here is that once I find the word, I don't have, I should say, so yeah, because the search word character is added incrementally, I should be able to filter the possible product words every character is added. So thinking of the data structure, the Trie is the one. So yeah, because Trie, each level of the trie is each character in the given list of strings. So every time I add the new word, the number of, the size of the subtree, sub correction to be traversed should be filtered down, reduced. So, in that way, trie is good. So, to summarize what I said, I can say, because I can filter down the word with the prefix every incrementally, so trie is the best option I can use. So if I'm given the word like this, probably I can use the trie like this. So B A E N N D N H. So this is bench. This is okay. Let me pick up some of the words. So bun. Yeah. Okay. So if, for example, if I'm given the word bun, bed, and bench, the trie should be like this. And from here, if I'm given the word, say, button, or maybe if I say, such word is B-E, bents, First, when I type B, I can, I need the root here. From the root, I will go to B, and I know that these were the possible options. Bun, bed, and bench. Also, when I type BE, I will traverse to BE, so this node. So I can say bed and bench are the two possible words. And for when I type BEN, I'm at the node N, so only bench is the possible option, suggested words. And when I type BENT, there isn't any node in the tree, so I can say there isn't any word I can return. The same for when I type the case when I type C. Okay, so this is the basic algorithm I can use with trie data structure. So in this way, every time I put the new character, I can go down to the tree and find only possible options. However, the problem here is that, say, when I type BE, how can I find every word I can suggest? Do I have to traverse those subtree to the bottom? It can take much time. So actually, something I know about this kind of search suggestion is that if this is a real world problem, like the Google search suggestion system, so possible words which begin from BE is cached in the memory. I don't know. So is a cache. I don't know if the cache is in memory or the storage, but I can say it is, memorization is used for that kind of and updated every day from the search index. But in this question, okay, let me allow to traverse to find possible words in this question. Maybe I can optimize it, maybe. Yeah, so probably one of the option I can use is, as I said, I will memo each word, which begins from this each node. Say like this. So here, I will just remember the word bench. Yeah. So here, so possible words, fun, bench, bench. Yeah. So it should be the trade-off of the space complexity and time complexity. So if I cache every possible word which begins from the prefix in each node, it takes much more space, but the time complexity would be, performance would be better. However, if I were to set the space, I don't have this kind of memorization cache in each node. So I have to traverse every word from each node. Okay, so here I will choose one with the router solution. So I will choose optimize the space complexity. So okay, so as that being said, the pseudocode it would be like this. So build try from product first, then for each char in search word, go down the try and from corresponding node, then reverse sub tree to find three suggestions and append them to suggestions array. Yeah, this is the thing. I will return suggestions. Okay. So this is a pseudocode. So let me do the complexity analysis quickly. So time complexity should be, I will go down to the tree in line 61, and this takes every times. And for each, it has to traverse to find three words. And because of the height of the trees, maximum height of the tree is L, it will take up to L times. Probably I will use backtracking to get the three possible words. But as I, just imagine the three possible words, a completely different one. Like when I'm at B, E, and then I have B, E, A, 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 B, E, B, 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 E, C, C, C. So in that case, I had to traverse three times L in the worst case. So yeah, this is the time complexity. And every time I find the word, I have to add it to the, returned array. And I can think that the returned array has at maximum 3L and L. Yeah. Okay. So yeah, that's the time complexity. So this is L squared. So yeah. And for space complexity, I need the space for Trie, which is Ln. And also I need the space for backtracking. So for backtracking, it needs the length of the call stack. So it should be L. Yeah. So this should be Ln. So comparing this line 56 and line 40, I can say if the any there, if there are many words in this array, in this, I mean, there are many products rather than L. So n is much bigger than L. This solution with Trie is better, more optimized. And it is the case in the real world because just think that so each word should be, I don't know, basically English words has maybe 5 or 6 characters on average. However, there should be many, maybe millions of product in the system. So yeah, it makes sense that n is much bigger than L. So I can say this Trie optimization, Trie approach is more optimized. Yeah. Okay. So that being said, let me do the implementation. So let me, if I will use this test case. And if I have the word, say, what was it? So battery is a bit wrong, so I will use but. In this case, this should return 3 arrays. And first 3, when I type BA or B, I should return banana, bun, battery. Also, when I type BA, oh, the same. Okay, so let me just reduce number of words. Banana. And when I type BA, it should return banana, battery, or result. And when I type but, it should return only battery. Oh, let me add one more case. So but, if this is but, it should return empty in the end, array in the end. Okay, so one thing I'm going to do is I don't want to sort these words, originally. I will just swap them so that I can confirm that the input can work. I mean, even if the input array isn't sorted, this system works. Okay. So this is a test case. Good. So probably this covers all the cases when there are more than 3 words, but there are more than 3 suggestions. Only 3 suggestions are returned. I checked it in the line 76, and in line 77, BE isn't included. So in line 77, I can confirm that only the words whose suffix matches is returned. And also in line 79, I can confirm that if there isn't any match, empty array is returned. Okay, so yeah, good. That will work on the implementation. So the first thing I have to do is sort product words. Oh no. I don't have to sort it in the trie structure. So because I will build the trie, I will define the node class of the used in the trie. I will use the hash map. This is the char to node hash map. And also, one thing I have to make sure is that if there is a word which ends with this, so this is true if there is any word which ends with this node. Okay. Yeah, so this is the node of the trie. Okay. So this being said, I will initialize the trie with this. What? So I would initialize the trie class. And yeah, so this is how I initialize the trie. So, and then what I should do is so probably this trie should have, yeah. Okay. For each char in search word, I will move trie.walk tree with char. So this updates the position in the trie. And then I will return trie.prefix this trie dot, so how should I say, much words, fixed graphics, more words, suggestions, words with current suffix words. Yeah. So this returns the first 3 words, which means which are the same, which has the suffix, which is the suffix with currently input, word. Yeah, I think this makes more sense. So here I will get, so and I will return suggestions. Yeah. So basically for every word in the search word, I will add that new character as the new suffix. At the end of the suffix, and then I get the 3 possible suggestions with current suffix words method, and I will append that current suggestion words to return the array suggestions. Yeah. Okay. So let me do the implementation. So here, one thing I have to do is okay, so this is the root node, and from here I will build the so types for each word. I start from root node, and if okay, so okay, so because okay, so let me change this implementation, self children. Let me do it with the length of characters, because from each node, I have to traverse the subtree from the lexicographically smallest character A, then B, C, D, E. So I have to know the order of that. So that's why I try to make the children nodes to be in a sorted array. Okay, so self-consciousness. So for each char, I will get the index of in the children's arrays here. So let me confirm something. So if each of the product words and search words, if they are lowercase alphabetic or not, I just check it in the LeetCode. Product consists of lowercase English letters. Search words consists of lowercase English letters. Okay, so that being said, this 26 makes sense. Okay, then self-constituent index. If this is empty, I will add new node here with current chart. Okay. Yep, and then after traversing each word, I will mark the current node, and here is true. Let me confirm. I will initiate the self-root node. Okay. And for each word, I will iterate. I will go through each character. And for each character, I will guess the index in the children. Then, if there isn't node in the throat in the array, I will initiate it. Yeah. Then, I will move the current pointer to that node. Yeah, okay. So in this way, I build the trie. And also because I will run some operation, run 93 and 96, I need to do the current pointer. Yeah, this current is moved through by this method is called. Okay. So here, this is the index in the okay. So if self.current is none, I cannot move it anymore. So I will just return. Otherwise, I will move the current node to the child. Okay. So anyways, so okay, so here in line 96, I moved the current. Yeah. So from here in line 90, from here I will implement current suffix verse. So what I should do is traverse each subtree, traverse the subtree and find 3 possible words. So that's the thing. So let me write something here. So just imagine that I'm as the node B. So if I'd like to get 3 words from here, and okay, just think that these words are the tail word, or yeah. Okay. So in this case, I'd like to return BAN, BAT, and BE. Yeah. Oh, and also if the words finish with B, I should, okay. If the word finishes with B, I mean, node B's end here is true, I should also include B. So it should be B, BAN, BNT. I have to think of these cases. So that being said, let me think. So these are the found words. So I will use the box tracking. So self dot wait. I also have to keep track of the words I've traversed before this B. Anyways, so yeah. So I will keep them in this way. So so now I get the self the current, and I will start traversing from here. So this is the chairs I visited so far. So So is this visit. Okay, so in found word, this should have 3 words or maybe 0, less than 3 words or equal to 3, which found software. So this would be updated in the backtracking method visit. Okay, so I will visit the node from set current. So method if if current node is known, I will just return. And if current node ends here, I will append it to set the fonts. Okay, so let me change this. Let me insert the suffix here. Okay, so here I will append this current word, current chart to set the charts. Then with that, I will traverse each method, each word. So no. So then next chair node is and I revisit it. So yeah, it's a thing. So then after that, after finishing all the traversal, I have to reverse the word chair appended to this. Okay. Yep. Also, one thing I have to do is the length of, bounds should be more than or equal to 3. So let me add something like this. So once I find that there are 3 words, I don't have to do anything anymore. So just return. Okay. Okay, so let me quickly confirm it. So I initiate self.choose and self.founds, and also self.visit. Okay. So I will start from the current node. So yeah, this one in line 110. And this internally visit method uses the backtracking and it updates the founds, yeah, word. So yeah, it returns, yeah, I will append each word to word, return word. Okay. Oh, I actually have to return this. So. Okay. But I try to make a copy of this first array and return. Okay. So okay, so this is back in 114. Business method is the backtracking method implementation. So if there's 3 words found, it returns immediately. And in 117, if current is known, do nothing. Okay. And in 120, I will append the current chair to the visited chairs after the current suffix. Then in 121, if it ends here, 1 word is found, so I will append the current word to the found array in 122. And then what I should do is traverse all the possible options. So I will traverse each index in the array. Wait, I actually have to do this. So I just have to use range 26. Yeah, and I revisit it. If this is next chair node is none, it just returns Yeah, in the query method in line 118, it just return no. So I don't have to care if the child node is no or not here. In line 125. Okay, so I think this works. Yeah, so I'm a bit tired, so I will run this code without walking through this code with my test example. Line 74. Line 85. Current children. Let's see. Okay. Line 85. If cut. Okay. It seems like current can be known. So when non-type object has no attribute children in line 85. Non-type object has no attribute children. Okay. In the initiation, it happened. Sorry, so in line 85, if this is known, I should create a new node and put it in the array. Okay, so line 94, so okay, this is typo. So in 100, line 100, it says try object has no attribute children. In line 100. I see. Yeah. In 140. So finally I got the error. So I will just print it out. Oh, yeah, it's almost there. But the thing is that B is repeated twice. The suffix is repeated twice. But so the end of the suffix, the character which is the end of the current suffix is repeated twice. Aside from that, it's okay. I see. So the problem is that, say, if the current suffix is AB, then I started from B, and this B is also added to the self.chars. So that's a problem. So, okay. So what I'm expected to do is in line 122, I will just include the final character in the current suffix. Yeah, so I will try it again. Okay, good. So the test case passed. So let me run this, my code in the LeetCode platform. So I will run this code now. I see. Okay, so the test passed. I mean, my solution was accepted. Yeah, so I can finish this question. So again, as a summary, I mean, quick recap, I can say I implement the trie to optimize the time complexity. And yeah, if I have more time and energy, I should have walked through my code with this example, and I can probably could notice my mistake when that way. Yeah, but it's okay for today because this is a quite heavy question with the trie, implementation. Okay, so I will finish my today's coding practice. Thank you so much. Bye.